All right, welcome to Lesson 10 in the Unit 2B module. What I want to take a look at today is solving a compound inequality. And if you think back a little bit what a compound inequality might be is, you just think about your English background knowledge. You were taught somehow that compound words had two words put together. And that's really what this is too. So, you know, this instead of having one inequality, x is greater than 4, we're going to have x is greater than 4 and or, same conjunctions actually, and x is less than, or greater than, say, 9. Let's make this a little, let's go, we'll use the less than term just so we have it, less than 9. So we get this idea of two different pieces. So we're really going to take two, and then really that compound means we're going to graph on the same line. So it's really not a huge difference. It's what we did in the last lesson. We're just going to rework it a little bit and add another component to it. Instead of just doing one on a line, we're going to do two. So let's take a look at how this works. So our goals today is that you can graph and write an inequality with an or inequality or an and as well as an and inequality. And you'll see that and or inequalities do not overlap, but and inequalities do. And that kind of makes sense. If you think back to a pretty simple connection, you can have chicken or steak. So you can have or, so you don't get both, or you can have and you would get both. So the overlapping is kind of you end up getting both answers, surf and turf, or surf and chicken. Or you can have steak or chicken, you can't get both. So let's take a look at what this compound inequality is. And that's really, this is the other way to look at them. What they look like are right here. So there's an or inequality, and literally it's written with an or. And an and inequality, we write and we'll write this another different way. There's a shortcut on this kind. There's also a shortcut here, but we're really not going to worry too much about them. But these are the two different types of inequalities we're going to look at. Remember, this one doesn't overlap, this one does. So let's take a look at the or inequalities first. So let's just take a very simplified version of this first example, and this is in your notes. X is greater than or equal to 2. So, okay, greater than or equal to 2. So, okay, we take a look. That's kind of something we want to graph. So at greater than or equal to 2 means we're going to close circle. Oh, I read that wrong. X is less than, apologize, less than 2. So we go, okay, less than 2 means we're going to have a line going this direction. And now we have X is greater than 3 with an open circle. This is really the idea behind it. And you can see they have a tendency to graph apart or separate. You see there's always going to, for an or inequality, you're going to have this gap in between where you cannot have an answer. So pretty much for this particular equation, there's only this from between 2.0000001 all the way up till 3.0. Those are the only numbers that are not right. So this gap just says they're not a solution. Pretty much every other problem would be considered a solution to this problem. So you can't have this number, and you can have that range. Anything above that number, anything below that number, and you're good. Okay. So this is where we're going to try another one of these. So you see it's connected with this or inequality, and you actually just choose to solve them separately. So you would go, okay, x minus 4 is less than -7, so we'd add 4 to both sides. So x is greater or less than a -3, and now we come over here, okay, and divide both sides by 2. X is greater than or equal to 6. So this is our equation, and we'll talk about interval notation once we graph it. So x is less than -3, so here's -3. So there's our -3 right there. And it's less, so that's all the way over here. Then we have x is greater than 6. Here's our 6, a little bit wider gap than the previous one. And it's greater than 6, so we're coming over here. So our interval notation comes from there, going saying, okay, now we take a look just like we did last lesson. So the arrows meant the infinity, so we have a negative infinity, and we always have those with the parentheses, up till a positive to a -3. That doesn't include the number, so it's parentheses. Or we start with a 6 this time, so you can see we start with a 6, and we go on forever, all the way up to positive infinity. And since it's infinity, we always end with the parentheses. So that's our interval notation for that. Okay. And it just kind of gives you the idea. It gives you that, okay, there's this gap. This is where there's that opening between the two, between -3 and 6. There's a gap between these correct answers. Taking a look at another one, same idea. Now, don't forget, there's a couple times you've got to be careful so that all those knowledge points we've talked about before of, remember, we flip your sign, like on number 2 here. We divide by -3, we get x is now greater than or equal to 3. Or we get over here, we do, we subtract this 5 now. This doesn't change anything. We get x is now less than 1. So these are our two solution problems. We flipped it around, so x is greater than 3. Here's our 3. It's at greater than or equal to, so we'll fill in the circle. Greater than puts us over here, and then x is less than 1. Okay, so here's our 1. There we go. Whenever you see an or inequality, for right now, you've got to think I've got, this means there is going to be a gap or a non-overlapping section. So again, we come back down to this graph over here. We go, okay, it starts with a -infinity, goes all the way up to +1, doesn't include +1, and then we start again back at a +3, but we do include the +3 and goes on forever in that direction. That's our idea over here. All right, so let's take a look at slightly more challenging. Now we've got this two-step equation. Doesn't change our process, it just helps us go through it one more time. So we'll subtract 9. So 2x is now greater than 8. Divide both by 2, so we have x is greater than 4. Now over here we're going to go, okay, subtract 10. 5x is less than 0. Now that's perfectly fine. Don't get mixed up on one of those special case ideas, or we're not going to look at those right now, because 0 can still be divided. So x is now less than 0. So now we've got two notations. We're going to say, okay, x is greater than 4. Goes on forever that direction, and x is less than 0, so it goes on forever in that direction. So we're going to start out with interval notation at -infinity, and this is really kind of the base idea of how these interval notation will go. It will always be this idea of -infinity to a +infinity for an or inequality. You just have to find that middle point in the center. Where's that opening all the way out to a +infinity? Okay. So this time I'm going to ask you guys to solve these two problems. I've got two answers just to make it easier on the flip chart, or on the multiple choice question. So you'll answer this one, and then you'll click right down here. You'll find the answer to that, the plug-in, and same here, and then I'll go ahead and do the interval notation at the very end with you guys, checking to see how that works out. So you'll have 3 different parts on this one that you need to answer. All right, so let's take a look. So pause the video and get to it, and then we'll see how it goes. All right, so I'm going to go ahead and walk through how to solve the equations. We're going to add 14. So we get 7x is greater than or equal to 14. And then we divide by 7. X is greater than or equal to 2. Now come over here, subtract 5. 4x is now less than or equal to a -8. Divide by 4, and x is less than or equal to 2, -2. Okay, so now you've got that. We take the second to graph it. Greater than 2, less than -2. So you can see our interval notation would be -infinity to -2, all the way up to these should be filled in circles, all the way up to a 2, and then goes on again forever in that direction. Good job on that one. So let's take a look at these and inequalities. So and inequalities have another way to kind of think of it. I've kind of shown you the entire notes, and they kind of graph together. And you can see how that will make sense as I graph these in a second. They'll overlap. X is greater than -6. So, okay, so there's -6 right there, and it's going to graph this direction. X is less than 1. It kind of graphs this direction. You can see they kind of, once they hit one of the points, they stop going. They don't go on forever. So you can see they're not going to have two things. They're not going to have those infinity notations on and inequalities. There's going to be a definite beginning point and an ending point, and that helps us with our interval notation. But there's a shortened way to write this, because the way it's written, a lot of times it's going to be written -6, okay, x, and a 1 like this. So we're going to say it's x is less than 1 or equal to 1, and x is greater than or equal to 6. So if you think about them separately, these signs look like they're flipped around, but you can see whatever number that sign was following, you can see it looking like the open mouth is on the x, the open mouth is here on this one on the x. That's where the signs are still pointing, even though they flipped around. That's another way you can see the same one written, okay? So, and the interval notation for this would have been just -6 with 2 all the way to 1, and that would be how you write it. This one's a lot easier interval notation. There's no infinities. So let's take a look at this one. So the one, because this is written in that shortened notation, it's a little bit different structure of solving. Instead of just saying, okay, I'm going to subtract 4 here, once you do it here, you've got to think, okay, once I do it there, I've actually got to do it on all the 3 parts of this equation. Part 1, part 2, and part 3. Those are 3 separate, distinct parts. Even though it's written shorthand together, you've got to be sure if you do one thing to one part, you do it to all 3 parts. So I subtract 4 from -2. 2 minus 4 gives me -2, and then we just drop our sign. Then we have just x left because those canceled. 9 minus 4, and that gives us a 5. And this is that shortened version of the inequality notation. Okay, so it starts at -2, close circle -2, all the way up to a +5, and then we connect the 2. Okay, so the key to this is always start reading here. Start at the x. Okay, so x is greater than -2. X is less than 5. And that's the trickiest part to work with on these. That leaves my interval notation, though, is my favorite part is 2 to 5. And that's my interval notation for this. All right, so let's take a look at number 7. So this one's got multiple steps, so I want to make sure I do this one with you. So we're going to add 13, but just like before, we add 13 to all 3 parts of the equation. So that leaves me here as a -14, 7x, and here 13 and 8, that gives me a 21. So now I'm going to divide everything by 7. So -2, since I'm not dividing by negative, I'm still good here. X and 3. So we start on a 2, or -2, and then we go all the way to a +3, and then we connect the lines. So it's -2, comma 3 with parentheses on both sides because there's no equal to sign. All right, let's take a look at number 8. So again, it's a 2-step equation. I'm going to ask you guys to go ahead and solve this first part on your own, then we'll graph it into the interval notation as well. All right, so we add 4 to all sides. So we get -12 is at 3x, and we end up with 6. Divide everything by 3, and we'll end up getting -4 is x and 2. So we get our -4 right here. We get our +2 on this side, and then we connect the 2 dots, leaving us with -4 parentheses, all the way exponent down to 2. All right, finishing us out. Now we've got some fractions to play with, and I'm going to continue to do these last 2 with you guys just because I want you to see all the different options here. So we'd subtract 1 from both sides, from all the sides, so we'd end up with -2, 2/3 x, and we'd have over here a negative or a +4. So we're going to multiply everything by the reciprocal, 3/2, 3/2. If you remember, that's how we kind of go through here. So this one becomes -6 divided by 2. Well, -6 divided by 2 happens to be -3. X here in the center. 12 divided by 2 happens to be 6. So okay, so we go from -3 right here all the way up to +6. We mark them together at -3, comma 6 with a bracket and a set of parentheses. Our last type comes through here with a distribute in here. So we're going 2x distributes. Now you don't distribute all the way across the other side, just to inside the parentheses, so it's -2. And then we have 2x minus 6 and 4. So we're going to add 6 to all 3 sides. So we get 4 2x, and then we'll get 10. Divide everything by 2. We end up with 2x and 5. So from 2 to 5, 1 with a closed circle, 1 open. Connect the lines so we go from 2 to 5 with a parenthesis and a brace. All right, so now you got the idea. Now you're ready to jump in and do your homework. If you have any questions, feel free to reach out and contact me.